Okay, ladies and gentlemen, welcome to our panel discussion. Today we will speak about computer science education for the 21st century. And I would like to start with my favorite slide, which actually displays so-called skills families that were indicated by 2-year-old Accenture research as those skills families which will be necessary for our kids to thrive in digital economy. And we can see that on the top of various soft skills which are included in these skills families, there is one important part which is related to so-called build tech know-how, and it is defined as skills and know-how how to use, manipulate, and create technologies and data. However, our education systems face major challenges in addressing needs of building the new skills in general, and when we talk about this build tech know-how or so-called digital skills, it is even more obvious that we lag behind. And maybe if you participated in the morning keynote, there was a nice sentence at the end of the initial keynote presentation saying that when we look at people and the new technologies, the major gap that we see is in the area of education. So today, with our panelists, we will actually discuss what is their understanding of the digital skills, what are the key digital skills young generation shall acquire, regardless of the career they will pursue in the future, and we will also discuss when and where these skills shall be developed and what are the efficient ways to do so, also given the challenges this area of education faces. First of all, let me introduce myself. My name is Alena Kanabová. I'm a senior manager from Accenture Slovakia. I've been working in IT for more than 20 years and participated in multiple systems integration and consulting projects. And on the top of my duties, I'm also a corporate citizenship lead in Slovakia for Accenture. That means that I'm responsible for the projects that we deliver in the area of social responsibility, targeting positive impact on our community. And I'm very happy today to be able to introduce our panelists. I will start with Professor Ivan Kalaš. Ivan is a professor of informatics education at Comenius University Bratislava, and since 2013 a visiting professor at UCL Institute of Education London. His professional interests include development of constructionist educational interfaces for programming and research in the field of the impact of digital technologies on learning. Welcome. Our second panelist, second from the left, Bühnová. Bara is an associate professor at Masaryk University, Faculty of Informatics in Brno. Maybe some of you could see her presentation recently. She's also a deputy chair of the Department of Computer Systems and Communications at the Faculty of Informatics of Masaryk University. And I would also like to mention that Bara is also one of very important persons behind the initiatives or organization Čekytas, which similarly to our local ITYT, welcome Petra, is actually focusing on attracting more girls and women to study and work in IT sector. We have also here Mr. Roman Baranovič, who's a principal of Narnia School. Mr. Baranovič graduated as a mathematics and informatics teacher, and he's really a big enthusiast when it comes to using the technology at school, not only for supporting the administration processes, but directly within the education processes. And the last but not least, we have Angelika Fogašová. Angelika is actually a graduate of Teach for Slovakia program. After her studies in England and Spain, Scotland, sorry. She actually came back to Slovakia. She worked in IBM, then joined Teach for Slovakia, and she had a chance to teach biology and computer science at the elementary school in Michalovce. And currently, I'm very happy that recently she has joined Accenture and she works as a backend developer. So welcome everybody. Maybe if you have anything to add to the introduction that I made? No? Okay. So maybe let's go further. So first of all, what I would like to do is to clarify what we actually understand under the term of digital skills. Basically, recently I have found a definition of the European Commission that defines digital skills in 5 areas. As ability to work with information, ability to communicate using digital technologies, ability to create digital content, ability to securely use digital technologies, and ability to solve problems using digital tools. So can we maybe drill down a little bit? Which particular skills are those that kids will need in their life? And why it is important regardless of their future occupation or career track, or also a social background. So I will ask all the panelists to provide a response. Maybe, Ivan, if you can start.
Okay, thank you. Well, this is a very hard question. First of all, I want to clarify that my perspective is slightly different. I would say that it's very important to distinguish between digital literacy or digital skills and those skills and experiences which computing education, computer science, informatics is aiming at. So I think that it's high time to distinguish these 2 sides of the coin, digital literacy and computational thinking. So if your question is about digital skills, then I think these are really, really very important. There are many definitions, and I'm definitely not going into any definition, which is always very dangerous. We all feel that this is very important for life in the 21st century. Actually, we see from our everyday experience how important critical thinking is, analytical thinking, being creative, being human. And I want to stress that although people, well, here are probably proud to say they are techies, they are in love with technology, and I am as well. My position is that digital technology is a brilliant way how to humanize education and our lives. So, well, this is maybe just a start.
Okay.
What stands out the most for me from the list you told us is the one with solving problems, because I saw it as a teacher with my kids that they give up easily because when they can't solve a problem, they give up really easily. And I think digital literacy or digital skills can help us solve problems easier, and therefore the kids experience less frustration. They are not so like the tendency to give up is smaller. So for me, it's also connected with the grit they have, and also with the growth mindset that you mentioned at the beginning.
Thank you very much. It works.
It works.
Okay, perfect. I'm really happy to be here. So thanks as a first thing to say. I really like the connection to the humanity, and actually Tim Cook, the CEO of Apple, said that technology should serve humanity, not the other way around, which very well expresses why technology is here. It is here to assist us. The problem we have nowadays, and I would place it on the first actually place, is that we have the information overload and opportunities overload in terms of technology. So we have so many technology accessible that we actually are not taking advantage of any of it because of the selection paradox and kind of like paralysis. So what I think we should be teaching kids is how to be actually able to effectively choose from the plethora of technologies, information, how to choose the one that will help them to drill down to effectively solving the problem that we were talking about. And having said that, I think that all of those that you have listed actually have a big importance.
Mm-hmm. Roman?
My take on this would be everybody learns in school how does the world and the planet Earth look like. Then we have the planet, then we have the atmosphere around it, and we are, as a humans, born into this planet. And in my opinion, the kids today are also born into another dimension of this planet, and I call that a digital world, that every child, at least in a developed society, is born into this digital world as much as it's born into this classical world with atmosphere and nature and everything around us. And it's quite natural for these kids to live in this digital world, really starting almost from the beginning of their lives. And as much as we always, for generations, were teaching kids how to learn in this physical environment, we just have to teach them how to live in this digital environment, in this digital world where they are born, where other sort of laws apply, and we have to help them to actually live according to these laws and help them to be successful, create relationships in this, maybe create things in this another dimension of the world. And this may be also a reason for the older people, it's so difficult to actually understand this because they don't know this dimension that well. It's not that natural for them as it is for these kids today. Mm-hmm. So it's it's not a question of should we teach them. It's definitely we have to do that. We have to raise kids in this digital world, and the biggest problem right now is that we actually really don't know how to do it.
Okay, thank you. So it opens actually a discussion on what actually is the purpose of computer science classes when we look at all these skills that we consider to be digital skills. So how the kids shall acquire these skills, and what is specific roles of computer science education in this, whether there are some other subjects which shall tackle this topic as well, etc. So maybe let's go deeper in this a little bit, Ivan. So what do you think, what do you perceive as a role of computer science in all this?
Okay, well, first of all, we don't have very clear meanings to these words, so there is one source of confusion, of course. In my perspective, I would say that digital skills and developing them has almost nothing to do with computer science education. And it's very important to realize this. Digital skills is, let's say, the new competency, new agency, which must and can be developed in every single subject. Mm-hmm. And this is what we are struggling with in Slovakia, in many other countries. Some of them are doing better. So then back to your question, computer science education, or as we call it in many countries in Europe, informatics education or computing now in England, our main goal there is to develop computational thinking. And you know, this is another word, so these are just words, yes, of course. But I think that digital skills are important instrument for learning, for living, for improving this damaged world. And everybody, every subject, every situation has to deliver to support development of digital skills. And maybe later, we may try to have some examples from some surprising connections to other subjects. But what we very often do, not only in Slovakia, everywhere, not having clear distinction between digital skills, digital literacy, and computational thinking, we think that these are the same, and we are somehow able to play the game that developing computer literacy is the goal of computer science education, and this is wrong, because we are losing time. We are losing time for what is important for computational thinking. Let me be very clear in this. Both of these aspects are very important in education, very important. But I think it's high time, and maybe we can say it started in a couple of years, 2012 and 2014, around these years. In England, when there was a huge report published by the Royal Society, where they decided, or they recommended to completely change the education in computing or in ICT or in digital literacy, digital skills, because we are missing something very important, and that's this computational thinking. Okay, so then the question would be, what is computational thinking, of course? So, and again, I'm definitely not going into any attempt to define it, but it's something like new opportunity to look at problems, new instrument how to handle problems through computational perspective, through what I would like to call computational curiosity. I want to create things, I want to learn, I want to explore using the computational way of looking at the problem, which usually is trying to somehow divide the problem into smaller problems, abstract, generalize, look for patterns in data, look for patterns in steps, in processes, trying to accept some rules, some constraints, how I can express the solution. So from computational point of view, the way how we share, how we represent the description of the process to solve something is even more important than solution itself. So in computational thinking area, we, and now I am quoting, I would say, the most important person in history of computational thinking, Seymour Papert, we want our pupils, our students to learn to think about programs. Programs are my thoughts. This is the way how to express my feeling, my approach, my strategy to solve a problem, and we can share these ideas. This is what makes computer science in education, or informatics education, different from mathematics, although we have a lot of common areas, I would say, or approaches, but focusing on how to explore data and processes is something very special, and it's not digital skills. This is not digital skills. Of course, they are very connected areas. They can help, they have to help, but we should be careful in building proper computing education, not to lose time, to be efficient, because it's so powerful. We have to learn a lot about this, but I think we have started, and this is really, really exciting.
Mm-hmm. Anybody else?
Maybe I would continue into the metaphor of the digital and the physical world. In the physical world, you have chemistry, biology, and physics, which helps you to understand the world. And if you actually know some physics, it might actually help you to do things better in the physical world. If you understand chemistry, it's probable that you can bake better cake than if you don't have a clue about chemistry. And computer science may be a key to learn to understand this digital world where we actually live in. Let's maybe explain that on Facebook. If you actually know what does algorithm is and what is data structure and how it's created, it helps you actually to understand better why those things are showing up in my newsfeed. If you have no clue about that, it's just something you read, it's just showing up. And you can learn about how to sort of make the font bigger on screen or maybe how to hide something, but without a computer education, you actually have no clue why exactly these things actually are showing up in my feed. And we have learned recently, in maybe last 5 years, that is actually very important what is showing in that feed, in that news feed, because it actually influences us, it creates bubble about us, and it's actually has some connection to the real world where we sort of do different things because what we have seen in that digital world. So for me, it's also very important to teach kids also this computer science so they will understand how the digital world where they live quite long, many hours, actually works.
Mm-hmm. Yeah, I can add also very briefly. So what Ivan said is I think really good expression of the idea. And just to wrap it up, basically computer science is about thinking and expressing solutions so that they can be automated. And only by that you can actually use the technology to speed up different processes that actually maybe now are taking our time, while we could spend the time with more human activities. And it's you can really automate the things that are the boring stuff without computationally thinking about it. So.
So maybe coming back to my question, so what actually shall be taught during the computer science classes? Is programming or coding, how we called it, something that shall be addressed during these classes? Shall it be the only thing, or are there also other areas that shall be addressed? And when we talk about coding, for example, why the kids need to learn coding, even in case just very small part of them will actually become coders?
Should I start again?
Yes, please.
Okay, so in my view, programming is the key concept of computational thinking. Maybe not the concept, this is wrong. It's a backbone of computational thinking. It's a way how we can cultivate and materialize our computational thinking. The problem is how to interpret the word programming. And this is quite unclear. Actually, what's happening in schools everywhere, in any country, especially in lower years of primary, let's say primary education, teachers are looking on internet for bits, for nice cherries, doing something, playing with a robot, doing this, that. And these are nice activities and actually exciting. But then when you ask the teacher, okay, what did we learn today? What was your learning objective? How do you know pupils met your expectations? And they just don't know, because we don't know. We are just starting to build a complex understanding of what programming is, what is the process of natural steps of growing complexity. These are things which in mathematics we have been discovering and trying to improve for centuries. And now it happens very well, almost in every country. In curriculum, in curricula, in National Program of Study in England, for example, which is very ambitious program, they would say pupils in primary key stage 1, which is age 5 to 7, will learn all the fundamental concepts of computer science. Wow, what an ambitious goal. And they should learn how to build programs, what are algorithms, using structures like repetitions, iterations, conditionals, variables in programs. These are so unclear goals. It's impossible for teachers to turn them into small coins to know what is the process, and we are learning this. So I think programming is incredibly important. In our development, we start in kindergarten. This is the age because these kids live in the digital world, as Roman said. The only, I would say, the most important thing is to interpret properly what programming at that age means, and respect what we call developmental appropriateness, to do proper things in proper time, so that we can start building this systematic learning process, starting here and going there, and knowing what we are doing today and why, what we did last week, what we are going to do next week, building this process. So back to your question, programming for me is incredibly important, and I want to stress again, but we must interpret it in a proper way. So for example, when I say kindergarten, usually when we know with a group of kids in front of interactive whiteboard, we know we are starting the very first preconcepts of computational thinking. Teachers, their parents, when they are coming, they think we are playing. And we are teaching, learning about animals, about fruits, about vegetables. But we know as designers, authors, and researchers that we are starting building that capacity of understanding. From child's perspective, I have certain tools, I have certain instruments, I can apply them to achieve the goal. And we can communicate together in front of the whiteboard, we can collaborate, we are learning together, we have a lot of fun, fine, brilliant, that's why we go to school, and we learn a lot. So it is very important, and we start as soon as possible.
Mm-hmm. Thank you. So we talked about programming. What about, for example, the area of security? Yeah, you mentioned the Facebook and the fact that the kids are living in the digital world. So when is actually the right age to open the topic of security, and what are actually the right topics to be opened at certain age, for example? You can, Varo.
Okay, so with actually children, what we recognize is that we are living in a world where we are constrained by also teachers we have available, by the background of the children, because some of them are actually having these kind of like knowledge activities from outside of the school, and some of them meet it for the first time in the school. So I think what is quite challenging is to say, because we are not really like in the education system, we are not really like driving it. We are a lot of like reacting to really diverse knowledge and speed of the different children. So it's very difficult to actually say the age for anything. You mentioned Facebook. It's a little like a different story, because Facebook is one of those like digital skills where we actually rather want to share and insights, knowledge, risks, and opportunities with children in kind of interactive and discussion environment. We do not want to teach them about Facebook. Maybe they will know more about Facebook than the teacher does. But these topics are an opportunity to actually like build up this kind of like sharing environment within the class. Because what we see is that in some of these like digital skills, also with, for example, communication and tools for communication, sometimes like engaging children to sharing knowledge about these and having the teacher as a moderator of such sharing might be a more effective way to do that. And actually, you only recognize by this how mature your class is about opinion on these things, and how you can actually inject also this really like critical thinking about the risks of these technologies, but also benefits. And this is not something that you could really easily like put in curriculum and say like in this week we do this and in this week do this. It's a lot about really the teacher being like conscious and actually being at least on a certain level of expertise in this knowledge, and being able to be a moderator of such like knowledge exchange. When we switch to computation and like these kind of things, then what we discovered is that you can start in any age. It's just about the way you start actually presenting the knowledge. And I really like also this information about like let's share the concepts. because you actually you can start with computational thinking without a computer. You don't need computer, actually. There are really beautiful projects, like, for example, CS Unplugged, like Computer Science Unplugged, where you do not need a computer, but you can sort out, you can put kids in a class and say, hey kids, so like each of you was born on a certain day, so could you just sort out so that you are sorted by the date of your birthday? And you will see like what chaos this causes, and it just doesn't lead anywhere. And then you say, okay, let's introduce an algorithm and let's just stay next to each other, and you will just switch if the one standing there is older. And let's see that after a little while, you're sorted. We applied an algorithm together, and we've learned something. And these things can be actually done in very, very small age. So the age thing is a difficult one. What I feel is that the stress is on actually the teacher and their ability to adapt to the class and being able to actually be quite agile in the teaching process. And I now do not want to like judge whether we make teachers ready for that or not. I just want to say that it's a really challenging thing to make teachers ready for this.
Yeah, and another fact is that we really actually don't have enough teachers qualified to teach computer science. For example, in Slovakia, we know that according to information of the state inspection, in 45% of inspected schools, they didn't have a single teacher qualified to teach computer science or informatics. So this is one of the problems, how to address it properly, this topic. But maybe question for you, Roman. Do you see any other barriers in this area on the top of this lack of qualified teachers that would be able to teach properly or to teach relevant content during the informatics?
I think the problem is that we really actually don't know what we should teach the kids because we don't have the experience yet, especially the older people. It's sort of like if I would be transferred now to Amazonia and I was asked to live in Amazonian forest for a week, I would probably die in a few days because I just don't know the dangers, I don't know the environment, it will be very new to me, even I maybe have watched some documentaries about that. And for most of the adults today, because they never grew up in this digital world, many of those things are new to them. And they really don't know what to teach kids about things they actually don't know. You can maybe have some curriculum developed by someone who actually understands and knows, but if you don't understand, it's kind of difficult to deliver that curriculum to kids because you are really like talking about things you actually don't understand and you really don't know from your own experience. And you best teach things you actually have some experience with.
I would maybe add to this. It's actually, as was said, I also was a co-founder of the Jakitas organization, and within Jakitas we have academies for teachers, and we talk to principals of the schools, and we teach kids many really coding classes and stuff like that. What we've experienced is also another challenge actually for the teachers is that just imagine that you are a teacher teaching like JavaScript to children. Then what happens is that you give kids the assignment, please write this like 10 lines of code, and they will come back and give you like 200 lines of code and tell you, but it doesn't work, could you repair it? Then like for the teacher, this is really a nightmare because I mean, even if they are on a like reasonable level of being, like in JavaScript, still, debug 200 lines of code without really being programmers, just being like teachers who do like lots of other stuff is really not easy. And actually, kids can very easily like find this piece of code online and this piece of code online and just connect it together, and then the teacher is left with like a nightmare really. So we just need to recognize that also for the teachers it's a really difficult task, and that's why like different concepts of like really helping each other, and maybe for the teacher also mediating the kids and actually leading them through the process of being able to debug their own solutions, rather than being the expert who knows everything and is able to debug everything for them. You know, changing this mindset that actually the teacher is the mediator who is helping them to learn, not really to just give them the skill set, you know, like this is how you should code. And this like mindset is a different thing, and it requires really a different view on education.
Mm-hmm. Maybe I will ask Angelika now, yeah, because you have the personal experience with teaching computer science, despite the fact you are not qualified in this area. So how did you do that actually? What did you do with your kids to make your classes really relevant, fill it with some relevant content? What helped you?
Yeah, like the content of our classes wasn't as hard as doing things in JavaScript. I was teaching 5th and 6th graders, which means like kids from 10 to 12 years old. So the content of it, or the level of programming or algorithms at that age is, for an adult, it's easy to understand it. So that wasn't the hard part. The hard part was to prep for the classes beforehand, because there are no books for teaching informatics, or however we are going to call it. Like, there are books, but they were like published in what, 2006?
Yeah.
Yeah, okay. So it's nearly
But
2000.
they still contain the real truths. It quite of doesn't matter if you have the book about Pythagorean theorem from 1600 or 2050, you know.
Yeah, so like the books they have 13 years. So yeah, they can be helpful with some like general principles, of course, but most of it the teacher has to do it on his or her own. And I have the great advantage of speaking English, but most of my colleagues, they don't. Like, none of them who were teaching IT at my school, they didn't speak English, and that's a big disadvantage for them, because they can search for the resources, for the exercises that are online. Then they can help you with teaching. Mm-hmm. So that was this part. And like for the approaches, I had a great community of IT teachers in Teach for Slovakia. So that was great. As all of us are like 30 or under, so nearly all of us were teaching IT, because at schools you go there, like, you're young, you go and you teach IT. You know how to work with computers. It's like the general assumption of headmasters. So yeah, we were sharing resources, and then there were some great courses offered by Ivan as well. How to work with Scratch and similar coding programs.
So are there tools available?
There are tools available, even in Slovak now. Scratch is available in Slovak. Code.org has been translated, nearly all of it as well. But yeah, you have to look for it. And this is something that is missing for the teachers, the support they need. If you are 50, 55, and suddenly they'll tell you, oh, here you go and teach informatics. 15-year-old kids who are like, who feel, and like they'll let you know that they think you know nothing about the computers. So you don't have the authority there, you don't have the knowledge, and it's just very frustrating for the teacher. So I don't feel like they've been supported in this.
Mm-hmm. I would add one information to this, which is pretty important. I mean, there are many tools, many things, but that's this like decision paralysis for the teachers. So they're actually scared that they will make a wrong move and choose a platform that will show up to be not the good one. So it's also by like really having support for deciding for the right direction. It's really something that they need support. Mm-hmm.
May I add to this as well?
Sure.
Actually, I think that expecting teachers to prepare the content is not fair. It's not fair. if you are an experienced teacher after 20 years of brilliant experience, then you start doing that. You start modifying, you start developing your own content. But expecting teachers to go into internet and look for what they should do is just not fair. It's not fair. Can you imagine this? You just send a teacher of anything to teach mathematics or language, and the only advice is prepare your content. It would not work. I want to add one more thing, that we have to distinguish between primary education and higher age stages. This is very important. In some countries, well, we have a lot of differences. In Slovakia, we have only 4 years as primary education. It's going through different countries to 5, 6, up to 8 in some cantons. In Switzerland, it's 8 years. And what is very special and fantastic about primary education is that most of the subjects, or all subjects, are taught by the same teacher, which is fantastic. We have to make benefit of this. And it includes informatics or computing as well. So when we are talking about teaching informatics or computing at primary level, the content should be developed for teachers in such a way that any of them will teach it. Otherwise, we are losing this fantastic opportunity of primary education. So if the teachers at primary level are expected to teach something which they are somehow like horrified by, then the content is wrong. If they can teach mathematics and physical education and arts, we have to come with a solution for computing, which they would say, this is brilliant, I can do that, and I feel I'm proud to do it, and I feel it's good for my children. But the other story is lower or upper secondary education, because these should be expert teachers, specially prepared. And if the reality is that a teacher is sent to teach computing, something is wrong. It will never work if we don't find a way out of this situation.
This is at the Maastricht University where I teach. We also have a study program for like teachers and of the informatics for the secondary schools. The problem is that we have no students. And if we do have students of these study programs, they actually go and teach, and there's kind of like professional education in companies. They do not go to schools. So I think that we are touching another problem, and that is that schools are really not having expert people in informatics or like information technology. And they are really like touching everybody, like, hey, you do physics, you will be good in teaching computer science, oh, you do whatever. And schools are suffering in this sense. There are no qualified informatics teachers from the schools.
Yeah, and actually we have a question which is related to this, how to tackle the problem of lack of expert teachers in informatics, because most people aren't motivated to teach, considering the salary difference against the private sector. So how to tackle this problem?
That will be my question.
Angelika, you know?
No, it's not like...
Share with us.
I know, or... like, my idea is when we take it realistically, we are not able to change the salaries of the teachers. We are not. That's out of our hands. We are not able to force people to work for the smaller salaries if they want to raise a family, buy a flat, etc., etc. So the only option we have is to train the teachers who are going to teach the kids anyways, to train them, to like make them not officially give them the qualification, because that's like, I don't know, it's 2 semesters or 4 semesters, 600 euros, whatever. Like, no. Let's prepare guides for them. So they'll know what is the objective, what should the activities should be for the class, etc., etc. And if they'll have this and they don't have to do it until 10 p.m. at home at night and not be with their family, and they'll just have it prepared, and they will actually, their job will be to teach, and not to create lesson plans and activities, etc., etc., then I think not every teacher will use them, even if they'll have them, but I think the percentage will rise.
Yeah, maybe an interesting fact when we speak about the lack of qualified teachers, it seems that we are not alone in Slovakia with respect to this issue. I read a nice statistics from the US saying that out of the 24,000 STEM teachers that go through teaching programs at American universities, almost all of them become math or science teachers, and 75, really 75, became computer science teachers on a yearly basis. It's horrible, yeah? And therefore, we have organizations like code.org, for example, which basically does what you suggested, Angelika. They actually train 75,000 teachers already, which are actually not computer scientists. These are English teachers and art teachers, etc., because they just realize that the kids will not going to learn the useful stuff if the teachers don't start to teach it. So they went for this course and started teaching it. But as Ivan mentioned, yeah, it's quite tricky because since they are not qualified, there is a high risk that they will not teach the kids the proper things anyway.
I would add to this, I was discussing this issue just last week with Ambassador of Netherlands in Prague because we had some meeting, and he told me that for them actually they solved it on a national level by having a hybrid teaching model where they have people in companies having like 1 day per week this kind of like teaching engagement. So these are people who work in tech companies, but for 1 day a week, they're just coming to schools, and during that 1 day a week, they are teaching at schools, they are teaching coding. And if something like this was possible for us on a national level, this will help us a lot actually. And for the companies, as part of like a social responsibility program, really freeing some of their developers interested in doing that, like having group of like high school students and teaching them programming would be one of those solutions as well. Just saying that it works in the Netherlands.
Mm-hmm. That's very interesting.
One of the reasons why we don't have enough teachers, not only in Slovakia but anywhere, is that they didn't experience computing and digital skills development when they were pupils at school. This is something completely new. And for almost 30 years now, we are playing the game. We have ICT subject, we have whatever. But it's not quite fair because there is a kind of like silent agreement, do whatever you want in this subject, you will learn something. This is not systematic and it is not integrated into subjects. If it is natural for every teacher, well, for ordinary teachers at school to use digital technologies to support the process whenever it is productive and safe and attractive, then those students will then graduate, and becoming a teacher of computing would be just an option. Because now it's a very special situation. So I think there are ways around it. And all of these solutions you mentioned and Alena mentioned are good, but I think they are temporary. They are temporary because we cannot do that with mathematics. We don't do that with mathematics. Fortunately, we don't have to so far. And well, we don't do that with many other subjects. I think we just have to start building the proper computing education and really finally, after all those decades, to find ways how to attractively, safely, and proactively integrate digital technologies wherever they can help learning.
I'm just thinking when I'm listening to these people here that lots of being said about the artificial intelligence at this conference. Mm-hmm. How about Accenture programming an artificial intelligence teacher of computer science? That might be an idea. You heard first time is here in Bratislava on OpenSlava that maybe it will come.
Well, I still believe that when you work with kids, you need this human touch in there. So,
because if you, this is sort of taking the idea of people from the companies coming to school to teach to a higher level. Because in many ways, it's actually, maybe actually better to have an artificial intelligence teacher instead of those people, because they don't have to be good teachers. Like if you are good programmers or you are good in selling things to the customers, it doesn't mean that you also have to be a good teacher.
I absolutely agree with you.
So maybe the really tune up artificial intelligence can be a better solution.
Roman, please stop it.
But
It's terrible.
no, but I mean, it's actually, I think it's just about a level, but it is happening. I mean, if you have the code.org, if you have any software development tool, and you have the IntelliSense telling you, do you want to write this function or this function? It's like, I mean, artificial intelligence actually trying to navigate you, what you might want to do. I think it's more about the form. May I also just add one experience? I wanted to emphasize one thing that Ivan said, and that is that the teachers nowadays do not have experience with being educated in these things. I see what we do in Chiquitas. One of the things just last week there was the EU Code Week. I don't know if you have it in here.
Yes,
I guess you do.
We actually participated.
Yeah.
in
So
it.
within EU Code Week, what we did is that in our Chiquitas Community Center, each day we brought some schools and we did the coding classes for 3 or 4 hours. Really like this kind of program, and we also had in the class the children and their teacher, and this was really wonderful because the teacher was watching. The teacher was watching how their kids are being educated in these things, and through this experience, actually really observing the teaching process and the learning process, being able to observe both, and these are two different things, right? Teaching and learning. They were able to kind of touch on what it means to teach this stuff. And often after this session, the teacher said, oh, I was myself surprised that this is something I want to do. And we had this within the EU Code Week actually every day different schools coming and educating, and we saw it as a pattern. And the teachers need to experience it.
Maybe another question which is linked to this, when we talked about the primary education, and about the need to teach kids this computational thinking already within the first grades. What to do if primary teachers don't want to teach it? Yeah, and this is not only maybe an attitude of teachers, maybe this may be also attitude of principals because they consider other subjects to be more important. Maybe even parents are not aware why it is important, so they don't push on the school to start teaching it. So
well, you are right. It's a very complex question. Actually, what we are now trying to do, and this is my agenda for my next years, develop pedagogy and content for primary teachers, go to school, what we are doing every day, last time today, for example, in the morning, and work with teachers and kids. In every school where we do this, I start teaching computing in a very young, small kids. In every school, after a couple of weeks, 3 or 4 weeks, the teacher who is there all the time would say, is this computing, what you are doing? Is this programming? I can do it myself. Brilliant, now we swap the roles. It happens everywhere, not only in Slovakia, everywhere where I work with schools. And we have a lot of schools, it's really growing. So my recipe would be working with teachers, developing proper content in such a way that they would fall in love with it. They would feel, I can do that, and that's good, and it's cool. And actually, back to Roman's horrible Kafka style of thinking. You know, in all modern educational settings, anywhere in the world, the role of the teacher is getting more and more important. more and more hard, more and more important. It is changing. This is another story. It's changing. But you know, of course, there are probably good places for artificial intelligence and support. Fine, yes, and that's fine. I want to learn something. I sit in front of my screen. I learn it. Good. We need this as well. But in majority of my time, we are learning together, we are working together, it's exciting, we are discussing. In our pedagogy, teacher never explains anything. The role of the teacher is to ask questions, give challenges and support discussions, organize the collaboration, and then finalize growing understanding, on growing experience. So actually, when I think about artificial intelligence replacing teachers, maybe it could replace bad teachers. Maybe it would be better than, I don't know, sometimes. But no, this is not a solution. We have to work with teachers. We have to change the conditions, make it attractive, work with teachers. Because very often they are just thrown into new situations without any support. We have to change this.
Okay, maybe I will come back to some of my initial questions which I had, because we were talking up to now about this creative side of digital skills, let's say, about programming or computational thinking. What about this non-creative side, the user side, where the kids, or how the kids shall learn how to use the applications that they will use in day-to-day life. Yeah, for example, for me, it's quite crucial that I can work with MS Excel or PowerPoint, etc. Is it the role of computer science classes at schools, or is there any other way how the kids shall obtain these skills? What do you think?
I think that nothing what is non-constructive, non-creative should appear at school.
Okay, so they should not learn it at all.
No, they should, but there are different strategies.
Okay.
Because,
can you elaborate on that?
Yeah, because actually when you create opportunities where I want to learn, I want to create, then in parallel with this, I learn a lot of facts, I memorize a lot of things, but it's not the goal. It's just like side effect of creating fantastic things.
Okay. So, what do the others think about this?
Yeah, it's actually like in the Czech Republic, there is an ongoing discussion that the Excel belongs to the math class and Word belongs to the language, Czech in our case, class, etc. The case is like you always need to balance. Like, do you want to have a computer on the table the whole day, also in the math class and in the Czech class, or like the language class?
Yes, I want to have a computer on math class and a language class.
Yeah. So, but this is a kind of a challenge. But I definitely like agree that you need to have a reason why you want to use it and why. So, the challenge should not be that I give kids a task to do just because I want them to use the tool. I should have a higher goal, and the tool just helps them to get there faster. But the goal should not be to do this, and this function in the tool. So it should be really a tool. It should be a means to get somewhere, and the somewhere needs to be meaningful.
Mm-hmm. Okay, and maybe another question, also linked to something that we previously discussed. You mentioned, for example, teaching coding in JavaScript. To what extent we shall teach the kids, I guess during the second part of the elementary education, to use specific language, for example? Is it useful, or when shall we start to teach the kids programming in certain language, for example? That's my question. That's something that's quite...
Well, you know, if I start talking, I will take too much time, so maybe I will be the last one.
Okay.
The reason is because Ivan's whole life was dedicated to actually develop the different environments and languages to teach kids programming. So that's the reason why he says that he will speak too much about it. I don't know. I think we have probably for now solve this question already with all those iconographic languages, which are actually quite easy to learn and are now done with in very nice environments, so kids can work with them and they learn the basic concepts with those like data structures and cycles and all those things, so they can learn that. And it's probably enough for most of the population to actually understand the concept of how the digital world they live in actually works. How much we should actually teach all the 13 years old kids JavaScript, that's probably something we can argue about. How much is that important actually? But there is actually one important thing in that. And in all those iconographics environments, they are quite easy. And those of you who actually are developers, and I hope you don't develop the professional software in iconographic languages, you know that it's actually difficult to program something. It's not that easy. And part of the problem with these iconographic languages is that kids get this notion it's quite easy. It's easy. You just click, 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 and you have the thing and it's running. But in the real world, the real programming world, to actually develop something, you have to really make the structures. You have to make all the functions, everything in the software, and then you have to debug it. And to debug the JavaScript, it's not easy, definitely. So it takes time and effort, and they learn patience and how to actually really go through some difficult things, which are not there if they do that only in those easy iconographic languages.
But maybe we have Angelika here, who actually learned how to program in Java recently. So maybe you can share your experience with us and maybe the biggest challenge that you faced when you start with that. And actually you are a great example of the fact that you can learn it in an adult age without the previous knowledge of programming obtained at the primary or secondary school.
Yeah, I just want to say I've just started, so I haven't learned it yet. Yeah, and this is one of the things that you guys were mentioning, that I, as a student, I haven't experienced any programming at my classes, and I'm 26, so I'm not that old, I hope. So it's not that long ago that I finished high school and I finished primary school, and I haven't had any classes that were different from typewriting. And then we had a test called History of Computers.
Ivan's hair has to go like this because he has dedicated his life to actually change this. Where it was? In which city? That will be an interesting question.
Well, my high school is actually it's a bilingual grammar school in Suchany. It's one of the best schools in the country, which is a sad story actually now when I realize that.
That's the best school in Slovakia for many.
Yeah. So yeah, and no, we didn't do any programming.
But it's strange because I'm much older than you and I did have some programming.
I don't know what happened there. Yeah, we had a teacher, and I still remember the class, and she told us in September, this is a computer. And we were like 16, 17-year-old people with smartphones at that time, like basic smartphones. And we're like, because she was one of the people, one of the teachers who was told like, oh yeah, you go and teach informatics, even though she was a physician or chemistry teacher or something like that. I don't remember. So for me, like, that's one of the things that maybe you don't have to teach the kids. They don't have to be experts in Python or in Java or in JavaScript, but they have to have an idea. I think you should show them the things, like give them the information and it exists. What is it used for? And if they like it, if that's something they're interested in, they can continue. They know the way. Like you open the door, to say it this way. So like, yeah, but you can learn it in older age as well. But I think it's much harder. If I started to learn when I was 10, as I was teaching my kids at school, I call them my kids, my students. Yeah.
You are really learning Java now.
Yeah.
So you should have sensors all about your body so that you can do research on how actually that influence your we can learn from this a lot.
Yeah, there are other girls from the course as well.
And actually,
I will just explain that these brave ladies participated in the training program that we organized during the summer in Accenture. It was very intensive 2 months program, and they successfully graduated it, and majority of them joined Accenture as a junior developers.
We within Chiquitas, we educate many young ladies who are most popular age is around 25, 30. They start with zero knowledge, and they are nowadays it's more than 10,000 of them. So.
Okay, but when we look at this experience, maybe provocative question for you, Baro. So why do we have universities for people to get the knowledge of coding if we can do it outside the university in the dedicated training programs like this one? So where do you see the reason of your existence, actually?
So I actually have the dual existence. So I have the university existence and then this informal education system existence. But just to summarize it, so what we see in tech is incredible complexity of the things we are developing. And I was earlier today I was talking about cybersecurity and about architecting really complex things. These are not things that you would deploy a person who go through a coding class or just evening coding class after their other job. So we need really people who are expert in this. I believe you can get to that level through informal education, which is happening outside of university. You definitely can, but it will eat much of your free time, and it will actually consume all your weekends and all your mental abilities and effort. University speeds up this. It speeds up a process. It just gives you when at university we teach kids about Java, for example. They get within 1 week 10 hours each week they spend with Java, right? And when you run like this for a year, you get pretty far. If you want to do that outside a university, you're probably working already somewhere, and it's not that easy. Having said that, it's actually good to say that the role of informal education out of the university is extremely high. I guess most of you know Stack Overflow as a discussion platform for developers. Stack Overflow is running surveys every year, and they are really interesting. Usually 70,000 developers participate in the surveys. And 90% of them claim themselves to be self-taught, self-educated, because the technology they are using today was not existing when 5 years ago they graduated from the university. So it's not because university would be useless, but the university couldn't really know what technology will come, so it prepared them for the ability to learn it, but they need to learn the specific technology out of the university anyway. So what I feel is, and what I'm trying to do is that we should have more conceptual approach to learning as a lifelong activity where universities, as well as this informal education platform, as well as industry, and their boot camps and growth platforms for education are all working in collaboration together.
Yeah, maybe this is a nice point, because it actually comes back to my initial introduction when I was displaying these skills families, and basically this cultivate a growth mindset, it was one of the key of them, which is actually related to the lifelong learning and ability to learn and willingness to learn constantly the new things. And this is becoming more and more important, and it will actually become a part of our life. But when I look at the question, because we have 15 minutes left for our very nice discussion, Maybe one question which is a little bit related to what we just discussed from the opposite side, but how would you explain a teenager who is to become a cook, carpenter, or a factory worker that computational thinking or programming is important for him or her?
Should I try?
Well,
yeah. Actually,
we can ask everybody.
It's too late. No, it's not too late. It's late. It's late. Of course, they should have started much earlier. Okay. But if you are in that situation, then you just have to understand what are their values, what are their problems. You have to find a way how to support them in solving what is interesting for them, solving their problems, where technology will help. This is the way.
Mm-hmm. To go with specific examples, so that's what we do in Chiquitas, actually. So we have that, we run different education programs. So many of them are for ladies, some of them are for like other groups as well. But for these ladies, we have, for example, Data Science Academy. This is one of the flagship things we do. It's like 3 months really intense course academy, including like pairing them with a mentor, having them doing like a really significant project, and learning a lot like Python, databases, data visualization tools, etc. But what we see is that sometimes there is, for example, a girl coming to this academy saying, I have an ice cream shop and I want to actually use data science to predict how I should shop for the ingredients. Because actually the taste of people is dependent on the weather, on the season, on the whatever, but there are correlations. And you can actually like use data really effectively to have this like mindset that some things can be optimized in our real world and save us lots and lots of time. Another such example was I just chatted last week with a colleague who was using artificial intelligence for Oriflame to combine their products into a catalog. He said that hundreds of people were deployed on this activity, like putting the catalog together. Well, an algorithm can do it, I mean, without any human intervention. And this is actually fantastic because we have so many, in these all jobs that you mentioned, we have so many like useless staff people, the occupied people, and could be actually be done automatically.
So through the examples, question for Roman actually. Many teachers would like to study more, but do not have the support of their director or principal. How to make the principals realize that informatics is a very important area? What's your suggestion for the teachers? You are one of the progressive ones.
I don't know if there is a solution to this, because people, especially when they are principals, they just have they see what's important for them. And if they don't see this as an important thing, it's kind of difficult to argue with them about it. So it's probably good to help them to understand that this is important, but there is lots of important things in life. Maybe if you hack the school, their school account, and send a good, interesting picture from their email address, they will get more interested in that subject.
Thank you very much. I'm actually teaching a day for principals in November. We want to, with Chiquitas, actually engage them. So more opinions welcome. So what else should we do?
I don't know. It's very difficult, of course. But I think, well, first of all, the role of head teachers is crucial in schools. Roman, it's you. This is my experience from wherever I go. The role of headmaster is the most important in educational system. So yes, it is important question, and then I would say we have to work with head teachers as well. I know in Slovakia, for example, I quite often hear head teachers complaining about very low quality of their professional development sessions. Well, we have to do them for them just to open, well, to open their eyes if they need it. But actually, in my experience, head teachers are very innovative and modern people in hundreds of schools, so let's trust them more.
I would just like to add that it's also not really ethical advice, but like nowadays we have, at least when it comes to primary schools, there are so many of them and so little kids that headmasters and headmistresses, I think, head teachers, okay, that's better, are fighting for every kid. So the parents have the power in their hands. If the parents will say, we want to increase the informatics from 1 to 2 classes a week, the headmaster has the power to do it, and if the parents say so, or else they'll put their kids in a different school because the other school is a 10-minute walk away, not 20 kilometers usually, the headmaster will do it. So it's in the hands of parents, I would say.
Yeah, but isn't there a contradiction with what is actually measured when it comes to evaluation of the success or the quality of the schools? Yeah, because we have these standard monitors, for example, which are aimed at Slovak language and mathematics. Nobody actually looks at informatics. So maybe this is actually the incentive behind pushing these other subjects in front of informatics. So what do you think, Roman?
There is lots of problems we have to solve.
Yeah, so...
And we are pretty good in naming them, actually. But yes, this is one of those. But then you will find out that you only test, and it's also not good. So, I don't know. Good problem.
I heard, for example, that the PISA tests, which are international tests, are going to test the digital skills also on the top of the basic literacy and mathematic knowledge. So maybe this could help as well, at least to show on what level we are here in Slovakia.
Last year, there was this kind of testing of teachers. It's called TALIS, and it's about what kind of skills teachers have. And teachers could apply for that, so I applied. So I wanted to know how actually this test, how it looks like, what is the experience going through this. And it was a hell, actually, I have to say, because it took me maybe 30 hours to actually go through all those tests, and it was very boring, and it wasn't the best experience in my life, definitely. It was a hell. So I'm not sure if actually adding more this kind of experiences to everyday life of pupils and teachers will add to sort of, we will learn more about it. It definitely was like when you are like a lab rat, and it's not a good experience to be a lab rat, you know, like they will push you, kill you at some point. So I'm not sure. Maybe it's okay to learn something from that and do few people who volunteer to do it, but I would not say like everyone should go through that experience.
Okay.
Actually, I think that measurements are important, of course, because it's an instrument how to learn how we are doing if we are spending our time in proper way. The thing is what to measure and how to measure. And actually, what is easy, and that's why most of the countries do it, just like having national tests. The proper thing, which is much more difficult to implement, is to measure how your kids, individual kids, manage to improve. It's nothing global. It's like if you have a club where you have young kids sporting, jumping, long jump training, then maybe it's less important who is the winner and goes to, I don't know, international competition. More important is when you entered our club, you did only 1 meter, now you can do, I don't know, 180 or 3 meters. Well, this is wrong number, of course. But this is important. And actually, I think there are ways and strategies how to make this work and implement in school.
And maybe this is also related to another topic which I wanted to mention, and this is the topic of the kids from the disadvantaged environment, which is a very special area. Angelika and her colleagues from Teach for Slovakia have good experience with that, but you also have a personal experience with teaching these kids and using the tools that you are a co-author or author of, with teaching these kids these skills for the future, including the computational thinking. How do you perceive this?
Yeah, it's a big challenge. Actually, we had the same experience in England when we were developing content using Scratch to support development of computational and mathematical thinking. And the evaluation, independent evaluation, proved that the most significant improvement was correlated to low social status families. So those kids coming from those families made the biggest development. And this is very interesting. And actually now we are experiencing very similar situation here in Slovakia, in Roma schools. We have a lot of them. We have the highest percentage of Roma population minority in Slovakia from all other countries in Europe. And actually, when you go there, you realize they are somehow underdeveloped in language. They miss a lot of experience from home, let's say. But they are okay. They are children like everywhere in the world. They just need attention, and they need proper opportunities to develop themselves, to challenge themselves. So actually, it's a theory. I am far from saying that I'm able to claim this is true, but I think that proper modern math education and computing education is a big opportunity for all those disadvantaged kids, because all of a sudden they feel like they are equal to everybody. They are equal. And if you measure them by writing essays, they very often fail. But here they are proud to see they can collaborate, they can talk, they can communicate in the class, solving problems, a lot of emotions. And what is very important in school, they are learning how to learn, and they are learning to be proud of themselves, to be proud of learning. So yeah, I think that computing is a fantastic opportunity if we implement it in a proper way to support these disadvantaged minorities.
Yeah, this is very interesting, because this is what actually teachers are telling us with their experience with the specific tools to teach computing. For example, for the kids with special needs as well, yeah, if they have dyslexia or any other special characteristics, they provide them with the opportunity to be good, to excel in this field, despite of their handicap, let's say. But Roman, sorry.
I wanted to add that there is also a dimension of security. I would say that even these kids from disadvantaged families, they still would have smartphones, and they will be connected to the internet as well as other kids. And if they really don't get any support from their parents, how to actually behave, how to be secure in this world, it's even more difficult for them, and in the long run for the society, if we won't be able to actually help them and show them around how to be secure in this digital world they live actually in as well.
Mm-hmm. Okay, we have like 2 minutes left. We have still some questions in here. I'm just scanning through them.
It's interesting. Actually, first time I see people are asking questions at the panel. That's good.
Yeah, that's.
I thought they are sleeping, but actually they're not.
They are actually asking, and not all of them are my friends. Don't worry. Okay, maybe the last question is kind of interesting because the others we partially covered already. There is a lot of talk about ADHD and autism causes that are technology related. How does one manage the risks a child is subject to in today's digital world? So maybe one final answer before we conclude our discussion. Is there anybody who would like to comment on this?
One of the privileges of being a principal at school is that I can really observe different families and their approach to technology, what they do. There will be families, they would say, no smartphone, no technology at all for kids. there'll be families like mine where there are tablets lying around everywhere, and kids can just pick them up. From that, and what I want to say is that I can observe different strategies, but I don't feel like there is a good strategy. I haven't seen like a good strategy now, because even in those families where they will lock out the kids from the technologies, at some point when they will enter the teenage age, they will just do everything to get to that world, digital world. On the other hand, even those who are sort of weak and they will let kids use technology, they usually don't know how to teach them to work with it the good way. So it's also a problem. So I don't know, but there are different strategies.
Angelika, you wanted to add something?
Yeah, I just wanted to add that it's really important, like, to talk to them as you would to any kid, and it's really important to make them feel that you are talking to an equal. You're not talking down to them. You're not saying them what they should do and how it is. It's more important, I think, to explain things and make sure they understood what they're saying, what you're saying, what are the consequences of some things, posting pictures, etc. Because kids at a very young age, they have Instagram, they have Messenger, and it's a risky business for kids.
Okay. Thank you very much. Unfortunately, we have run out of time. I think that we would be able to continue for more hours and hours.
I'm pretty sure we will not. We will not be able to do that.
Okay, but we named many issues, many problems. Maybe we didn't come with solutions. At least maybe what we can conclude is that this digital age represents many challenges for us, but on the other hand, it brings for us great opportunities, for example, for the disadvantaged kids, as we could hear. So I would like to thank to all the panelists for today's nice discussion, and also to the audience, and looking forward to the panel discussion maybe next year in OpenSlava. Thank you very much.
Okay, thank you. Have a nice weekend.